Hello everyone, this is Sherry's channel, and today I will take you to review the December monthly exam. I will focus on reviewing the fundamental theorem of calculus and help you to earn more scores in the exam. Okay, first of all, let's check some basic formulas here. You can see the fundamental theorem 1. The first one. Just write it down. The integration from a to b of f of x, we can write it as the definite form integration f of b minus f of a. But at the same time, we need to know that in the Riemann sum, we just can write this as the area from a to b in the graph of f of x, right? Okay, the graph is about the f of x. And here are some properties. First of all, we can remind you about the constant multiple. If we want to write it the constant k, then we can write it as this kind of. Okay, and the sum and the difference, we can just break the integration into two parts. Yes. And something about the zero, if we have the same upper bound and the lower bound, we just write b as the lower bound a. Then no matter what kind of fx is, the integration equals 0. And sometimes we need to have some exchange about the upper bound and lower bound. Then we need to get the negative symbol here. And you can have some additivity here. We can just keep them apart from it. Okay, all right. Here are the formulas you are very familiar with. And about the second fundamental theorem of calculus, we can see. Okay, I will change the color. We can see the function as accumulation function, and we got the variable t as the dummy variable, and then we can see the the second FTC. Just write it as d over dx of the integration. Okay. You do the antiderivative and then you do the derivative, and so that equals you do nothing to f of t. That means the true variable is x, so that means it is f of x. And always don't forget, here it equals 0 because a is a constant. A is a constant. And sometimes we will change the upper bound and the lower bound as a function of x. So we need to use some chain rule. We can just write it down. Okay, we can use a chain rule. Write the upper bound here, but chain rule of it, the beta prime and minus. Okay. So here are the formulas, but sometimes you think that the question about the FTCs are difficult. Now we have the table here, and let's check together to make sure that you can get some conclusion to help you learn it easily. Okay, about this kind of table, we can see that we have the g of x is the integration of ft, and what happened to the f of x in the graph. Actually, we write it down like this, and then we could find that here is some kind of fx, right? Okay, that means if we have the questions about the gx, we can see that so many of them. Gx value, horizontal tangent line, concave up, concave down, but the graph, you can see the graph. It's about the fx, just inside here. Or you can just write it, use the FTC, the second FTC. So we can just write it down as g prime x equals fx. Right? Just here. This is the gx. Right? d over dx, so that means g prime x. So you get the graph of g prime x, the derivative function, but all the questions are about the function of g of x. So we need to write something more here. G prime x equals f of x. So g double prime of x just equals f prime x. Okay, so the graph is about the g prime. If we want to get the value of g, we just wanted to see gx equals a to the x ft dt. So if we wanted to get some kind of gx value, then we can see the area from a to x. For example, I will give you the here that like x equals 3 and a equals 0. So it's the area from 0 to 3. And g prime x is just in the graph. So it's the fx value in the graph. It's the fx value in the graph. Okay, double prime, it means the value of f prime x. So about f prime x, we just find the slope in the point in the graph of that point. And when gx is increasing, we can see g prime is positive. So fx is positive. So the part which is above the x-axis. And if gx is decreasing, then g prime x is negative. So f of x is negative. So the graph, which part is below the x-axis. Below the x-axis. Okay, when gx is concave up, then we can see double prime is positive. So f prime is positive. So fx is increasing. And for gx is concave down, we can see double prime is negative. So f prime is negative. So fx is decreasing. Okay, for the gx critical point, then g prime x equals 0. That's enough. We don't care what happened on the left or on the right. So we can just see the 0 point on the graph. And about the local maximum. For the point of local maximum in the g of x, we can see the graph looks like here, that, right? So we can see it from increasing to decreasing in the local. So we can just see that g prime changes from positive to negative. At the same time, we can see g prime x equals 0 or does not exist. Most of the time, it is larger. It is equal to 0. Only a few times it does not exist. Okay, we always just write the g of g prime as fx. And about the local minimum, we can see just like this. So g prime x equals fx. It changes from negative to positive. At the same time, fx equals 0 or dne. About the absolute maximum or minimum, first of all, we look for local maximum or local minimum. That's the 0 point and change sign. Okay, so we can write it of f of x, and then we check the value of the endpoint, the left side and the right side of the whole interval, and then we just compare them. Okay, about the inflection of the g of x, we just call back the concave up and concave down. The inflection point is the point where we can see the change of concavity. So the concavity of g of x, we can see it as the increasing or decreasing of f of x. So if we wanted to see the g double prime change sign, we can see f prime change signs. So if f prime change signs, we can see fx changes from increasing to decreasing, or changes from decreasing to increasing. So in the graph, we will check the point of local maximum or local minimum. And about the equation of the line tangent to the graph, then we can just write it as y minus y0 equals kx minus x0. So x0 equals c, and here is g of c, and this kind of k is f of c. It's right. And if we can get some horizontal tangent line of g of x, then g prime x equals fx equals 0. So you always check the 0 point. Vertical tangent line fx d and e does not exist. Okay, so here's a table I wanted to show you, and sometimes you could get some conclusions by yourself, and then you can just write things down and check your answer. Okay. If you are still confused about the derivative application, then we can just see it here. If we wanted to see fx increasing or decreasing, then we see the prime of fx positive or negative. If we want to see fx concave, sorry, but I just can't write it smoothly. Concave up or concave down, then you can check the double prime, positive or negative. At the same time, you can check the f prime, increasing or decreasing. Yes, and then you need to get some local or absolute max minimum, and sometimes you check the critical point and inflection point. They are always in the questions of FTC in the AP exam. And here we can see one kind of question here. The graph of the graph shown above consists of semicircle and a straight line segment, and here it's a graph of f, and all the questions are about g of x. So first of all, we can solve question 6 and question 7 and then return to question 5, because absolute minimum it need more calculating, so much counting work here. Okay, first of all, we can see all values which g attains a relative maximum. Okay, g attains a relative maximum, so what happened to g prime? G prime equals f changes from relative maximum positive to negative. Okay, in the graph, here we can see 3 0 point. We check the 0 point. Here is from the negative to positive. Here it changes from positive to positive, and at x equals 3, it changes from positive to negative. So we can see x equals 3. G has contain a relative maximum. And question 7 is about the point of inflection. In the table, we can see that if we wanted to get the inflection point of g of x, then we will look for the critical point. Not only critical point, but the local maximum and local minimum in the graph. So critical point and local maximum, local minimum, something happened from increasing to decreasing, or from decreasing to increasing. So we can see it here, 1, 2, 3. X equals 0 is not the inflection point because it's changed from decreasing to decreasing. Okay, so it still needs some kind of verify because he just write it as find. So you can write it as G double prime equals F prime, change sign. So we can find the local maximum, minim in the graph of f of x. So we can see x equals -3, 1, and 2. Yes. Okay. And the final question, question 5, absolute meaning. So we can see the local meaning here. X equals 1, 2, 3, 4, -4. And we can see the endpoint here. X equals -5 and x equals 4. So we need to check the 3 area here in the graph to get the integration, because the integration is the value of g of x. First of all, we just write -3 to -5. And we can exchange the upper bound and the lower bound to make sure that the area is the correct value. Okay, from -3 to negative, from -5 to -3, and it just can be right as 0. And it is the value of g of -5. G of -4, it equals -3 to -4. Okay, get the exchange. And you can just write it. Okay. -4 to -3. The value is 1. 1 multiply 2, multiply 1 over 2 to get the area of the triangle. But here's a negative here, and so the answer is -1. And about the value of g of 4, you can see it as obviously positive one, right? From -3 to 4. The area is 9 over 2 plus 2 minus pi over 2 and plus 0. So it's because the -1 is the most small one, so we can see that absolute meaning value is g of -4 equals -1. Okay, that's the question in the question bank of College Board. Okay, and we can see the question here. It's the graph of f prime, and all the questions are about f. It's okay. You can always use the table. Why? Because here we can see the right column, it's all about g prime x, and the left column is just all about the g of x. So it's okay if he just wanted to show you the graph of f prime, and then he asked the question about f of x. Okay, here is some kind of condition. F of 1 equals 3. Semicircle, 2 line segments. Okay, and the first question is relative maximum. Okay, relative maximum, we can see f prime changes from positive to negative. So, x equals -3 and x equals 4. Okay, question 9. Inflection point. For the inflection point, we can see f prime x changes from increasing to decreasing. He just asked you to justify your answers, so you need to write them down neatly, clearly, and just write it more if you wanted to get more points here. Don't just give me some kind of this. And vice versa. So you can just write this down to help you check. Local maximum or local minimum in the graph. So local maximum, local minimum, x equals -4 or -3, and -1, and x equals 2. Okay, concave up. F is concave up, so f prime double prime is positive, and f prime is positive. So you need to write down f prime is positive and f prime is increasing. Right, check the table again. If gx is concave up, then fx is increasing. Okay. So in the graph, positive and increasing, positive and increasing, positive and increasing. So we can see the interval is -5 to -4 and 1 to 2. Okay, final answer question is absolute minimum. The same steps as question 5. Okay, absolute minimum. I just write it here. First of all, we check the local minimum. X equals 1, and we need to check the endpoint. X equals -5 and x equals 5. Okay, here the question is very nice for that it has shown you f of 1 equals 3, and then we based on the f of 1 to calculate, and we wanted the area 1 to 5. The area from 1 to 5, it equals 3 minus 1 over 2 is 5 over 2. Okay, that we can use the first FTC. It means f5 minus f1. So f5 minus 3 equals 5 over 2. F5. It is larger than 3. The same for the question about -5. We can just write it as -5 is the lower bound. It's okay because it's smaller than 1. We just write it down so that we can just use the area. It is -3π/2. Okay, it's pi/2. I don't need this kind of vertical line. It's 2 pi. Okay, it's f of 1 minus f of -5. So f of -5, it equals 3 plus 3π/2. So it's still larger than 3. You want the absolute minimum, so the answer is f of 1. Okay. Hope you to get familiar with the table and get a good GPA in the test. Bye bye.